Hello, good afternoon. So we'll start in 5 minutes. What does it look like? नहीं, इसको जूम करें ना। और ऐसे आ रहा है डिफरेंस ठीक है। ये आ गया ठीक। ये ऐसे आना चाहिए था। हेलो। और बढ़िया, तू बता कैसा है? बाबू कैसा है? बस बढ़िया। हो गई सेटिंग रूम की? तुम्हारे सब बात यहाँ पर Hello, good afternoon. I am audible.
Yeah, sir. Good afternoon, sir.
Okay, thanks. So today's classes we are mainly just looking at previous problem, and if you have any doubt, we can solve here.
Okay, sir.
So my screen is visible now. No? My screen is visible.
Yeah, sir. Yeah, sir.
Okay. So good afternoon, everyone. So before start today's classes, I will introduce about myself. So I am Probir Maiti, teaching assistant of this course. The course name is Introduction to Polymer Science, and course instructor Professor Divakar Dhara. So, so in this course we are mainly known about that how a polymer we can synthesize, how we can process the polymer, and during this from that synthesis to process to final product, we are going to some related topic according to that polymers. So how we can measure its molecular weight or how we can measure its property or like that, and we are solving some problem related to this course in these courses. So today I will mainly focus on that the problem related to that second third week, and also some related problem that earlier classes, not this week 7 and week 8 related courses. So from the starting, so first when we start our courses, so we'll talk about the polymers. So how we can, so from the polymer, how we can calculate that polymer molecular weight, like that. So there will be various, when we discuss about that polymer molecular weight, so then we're talking about that average molecular weight, because when you talk about that polymer, so we are not talking about that single molecule or single polymer chain. So there the multiple polymer chain are present, and it's not possible that every polymer chain have that similar chain length. If they have that similar chain length, then we are not talking about that various type of molecular weight like mn bar, number average molecular weight, weight average molecular weight, viscosity average molecular weight, or Z average molecular weight. If their chain length are same, if their chain length are not same and they are the mixture of various chain lengths, so then we're talking about that can we average this molecular weight in the basis of number, in the basis of weight, like that. So for this, that calculation of the number average molecular weight, so this is the equation where we can directly get an idea that how many number of polymer chains which have the similar number of molecular weight divided the total number of polymer chain. So from here we can get about the number average molecular weight. For the weight average molecular weight, we have to do like NiMi square divided by summation of NiMi. For Z average molecular weight, it will be NiM cube divided by NiMi square. So from this equation, it will be clearly tells about that your Mn should be lower than Mw than Mz. So there another molecular weight, which is the viscosity average molecular weight. So why this viscosity average molecular weight is needed? Because when we are doing the processing of the polymer, so when you're talking about the polymer, like last classes we are talking about that polymers have some viscous property, like it have some damping property or like some viscous property, like when the polymer is melting, when you're melting the polymer solution, so it's not like a some like a water like solution, it's have some different property. So it's have some um, viscous property, like its resistance to flow, like that. So for this reason, we must acknowledge this viscosity average molecular weight. So for this reason, we are taking about another average molecular weight, which is that viscosity average molecular weight. That equation is will be like this. So when you're doing the distribution curve, the molecular weight, so it will be should be like that. First will be your Mn, number average molecular weight, then Mv bar, viscosity average molecular weight, then weight average molecular weight, then the Z average molecular weight. So in that first week of classes, we are mainly focusing about that how we can calculate that polymer molecular weight, how that equation, from that equation we can calculate the molecular weight like that, and talking about the general polymer, that how this polymer is look like, how the polymer will be fast coming, like bakelite or like that. So like we have solving some problem related to this, that the number of moles is there and their molecular weight is there. So from there we can calculate its molecular weight. So if you someone asks about that weight average molecular weight, so we can easily calculate this. So from that Ni and Mi, so if the Ni Mi is given, so from there we can calculate the Ni Mi square, and also we can calculate that Ni Mi. So from there we can calculate that Mw, and also we can calculate that the number of molecular weight. And we know someone talking about that how will be its PDI. So PDI is nothing about that ratio between the weight average molecular weight divided by number average molecular weight. So from there we can calculate that PDI. And if the PDI is 1, so that will suggest that every polymer chain length are similar chain length. So your weight average molecular weight and number average molecular weight should be same. But no polymers have that this property. So with that, generally synthetically polymers have that PDI which generally greater than 1. So that means that we cannot synthesize any polymers which have that similar chain length, or that where that number average and weight average molecular weight should be same. So this calculation we can easily calculate like that. We can calculate that number average molecular weight average molecular and PDI. So in this week, so mainly we are focusing like this type of problem, or sometimes the mole fraction is given. So from the mole fraction also we can calculate that number average molecular weight and weight average molecular weight. Also, if the PDI also given and number average molecular weight given, so we can calculate that weight average molecular weight also from this equation. So from the next equation where that weight average molecular weight is given, so from the weight average molecular weight, so if someone calculate that weight fraction, so from there that number is molecular weight equation will be like this. So it will be 1 by summation of Wi by Mi, weight by its molecular weight. So from there we can calculate that number average molecular weight. We can calculate from that directly WIMI equation. We can calculate that weight average molecular weight, and from there also we can calculate that PDI of that polymer. So then the next classes we are talking about that mainly about the condensation polymerization. So when we are doing that condensation polymerization, so there that involvement of some functional group. Like if you want to make that amide, so you have that some amine group is present and some acid group is present. So that make the amide bond. But when we are talking about the condensation polymerations, to make a polymer, so you need a dual functionality, not a single functionality. So only the single, like only one amine and one acid cannot make that polymers. If they are diamine and if they are diacid, then it will be synthesized that polymers like that. So when that condensation polymerations that coming, so we know about that average functionality, that how much functionality we can calculate. So if that, like if there will be the molecule will be like that, where there will be functional, that one molecule have the three functional group, another molecule have the two functional group. So how will be its average functionality? So to calculate the average functionality, the equation will be like this: that functionality of that molecule into its mole in plus the functionality of the second molecule into its number of moles divided by total number of moles. So that will give that average functionality. And if you calculate that average functionality, For this molecule like ethylene glycol and glycerol, which have that three functional group, while the ethylene glycol have the two functional group. And if they are less similar molar ratio 1 is to 1, so we can calculate that average functionality. So it will be like 2 into it's that number of moles, it will be 1, and for that glycerol it will be 3 into 1 divided by total number of moles, so 1 plus 1, it will be coming about that average functionality. So from this average functionality also we can calculate that PC, that how that reaction will be going on beyond its gelation point. So it will be, so that equation will be coming less. So that's the here that mainly that related problem about that how we can that if the two have that similar mole fraction like 1 is to 1, so the molecular weight would be like this. And if there will be something like that, we are getting that reactivity ratio. So what the reactivity ratio it suggests that how the second monomer is taken, that the ratio between that first monomer and the second monomer. So the first cases we had that R is almost 1. So first and second is almost 1. So from that we can calculate that from the Carothers equation we can diagonally calculate that degree of polymerization. So degree of polymerization will be 1 by 1 minus P. So if that percentage of conversion will be like around 99.5%, so we can calculate the degree of polymerization of that molecule. So if we calculate the degree of polymerization, so we can calculate that molecular weight by knowing about that what are involving in that uh, in this polymerization. Like in this case is the adipic acid and hexamethyl diamine. And if you go that the molecular weight, so repeating unit molecular weight should be divided by total molecular weight divided like repeating divided by 2, because here the two functional group are present. So you have to divide it by its functionality. So if the two functional group are present, so that if we calculate, so for this cases the repeating unit molecular weight is coming around 226, right? So from the 226 you have to divide it by 2, so it will be coming around 113. That will be repeating unit molecular weight. So from that we can calculate the molecular weight of this polymer. So now in these cases if you add some adipic acid, some little excess, now, now, like that, Carothers is told that when you the excess that some when you are not accurately weight your second monomer, so you are losing your molecular weight. Like earlier, your when there will be 1 is to 1, your degree of polymerization is 200, like 200 repeating unit is there. But only 1% excess you added adipic acid. Now the equation will be completely different, and also your degree of polymerization is also different. So now it will be like 100. So you are losing your molecular weight. So this equation you have to remember for that exam. Like when there will be one is to one. So how the equation will be, and when there will be the sum excess. So how the molecular weight will be like look like. So for this condensation polymerization, here that another things we are introduced about that that monofunctional impurity. So what is the monofunctional impurity? Like that when that polymerase is going on, there will be two functional group are present. So from the two sides, it will be starting the polymerization. Like it will be acid, and its side will be for the ester, it will be alcohol. But when there will be you add some group like that, when there will be only one functional group, like a benzoic acid. So only that benzoic acids react with this alcohol, but here there will be nothing that next functional group is present. So here that your polymerization will be stopped in these cases. So with adding the monofunctional impurity, we can control that molecular weight of this polymer. So for these cases, if we add some monofunctional impurity into this polymer solution, so we are increasing that. If we add some acid, so you are increasing that acid concentration. So for these cases, the similar that 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 conversion is similar like 99.5, but you are adding the monofunctional impurity, so you are losing the molecular weight. Now the degree of polymerization would be, it's more reduced, it's around 60, 67.3. So it will be reduced with increasing that monofunctional impurity into this polymer. So now that the ratio of reactivity ratio, so like one is the 100% is the amine, but not, but now that acid concentration is changing, so for the acid will be 100, and for this 1% of adipic acid and 1% of excess of the benzoic acid, so it will be coming 102. So from there we can calculate that degree of polymerization. So from this we are solving some problem in week 2. The problem it will be like this. So this question I am taking about from this your assignment 1. So the weight average molecular weight of an equimolar mixture in adipic acid and hexamethyl diamine, it's given 33,900. So from there we can calculate, like you can calculate the repeating unit molecular weight, and repeating unit molecular weight, it will be divided by its average functionality, so we can get an idea about its, that repeating, that m0 value, that effective repeating unit molecular weight for this calculation. So you get the calculation of m0 value, and here that weight of the polymers is already given 33,000. So from there we can get that degree of polymerization. So degree of polymerization related to that XW, like weight average degree of polymerization. So from that you get that degree of polymerization, it's about 300, and you know that equation like Xn equal to 1 plus P by 1 minus P. So if you put here that in that equation degree of polymerization divided by, you have to calculate that percentage of conversion. So we can put directly, so we can get that percentage of conversion. So for the number average molecular weight, so this will be 1 by 1 minus P, but when we are going for that weight average molecular weight, so it will be 1 plus P by 1 minus P. So you have to remember like this equation. The like in during the problem solving, I am in one slide also I am given like that equation, like for that xn bar, what will be the equation 1 by 1 minus P, for xw bar, what will be the equation. So if you remember this equation, so only you have to calculate that repeating unit molecular weight, and from there we calculate that degree of polymerization, and from there we can calculate that percentage of conversion easily. Now the next question will be like this: the feed ratio of adipic acid and ethylene glycol should be employed to a polyester which the number average molecular weight given is 12,900 and the 98% conversion. So you have to calculate that feed ratio. Like we have to calculate that react R. So if you want to calculate that R, so here it suggests that they are not a similar reactivity ratio. So like your R naught should be 1. So for this region, so you have to come this equation where the degree of polymerization is is related with your reactivity ratio, and the equation will be like this: xn equal to 1 plus R by 1 plus R minus 2RP. So here already we know about that xn how we can calculate. So from that calculator, from the repeating unit molecular weight, so here the average functionality is 2. We can calculate that m0 value. We can also calculate that repeating the degree of polymerization. So you know the degree of polymerization, and also you know about that percentage of conversion. So then we can calculate that reactivity ratio from this we put here, and from here we can calculate easily the reactivity ratio. So in this problem we have to remember about that that which molecules are involved in this polymerization. So you have to knowing about that how this ethylene glycol is, how it's that molecular weight. You have to calculate this one, and from there you can easily get that repeating unit molecular weight. So here the main problem is that you have to calculate the repeating unit molecular weight, and you have to know about that when which equation you have to need it, when you have to take in that xn bar equation, when you have to take in that xw bar, depending upon that what molecular weight is given. It's given the number average molecular weight or weight average molecular weight. So from there you can easily calculate the reactivity ratio, or you can calculate easily that percentage of conversion, or if the reactivity ratio is given or percentage of conversion given, we can calculate that degree of polymerization, and if the degree of polymerization you can calculate, we can calculate the molecular weight. So from this Carothers equation. So there will be another is the statistical distribution of the molecular weight in this like condensation polymerization. So statistical distribution will be like this, related with that mole fraction. It will be nx, which is the number of moles of the degree of polymerization at the conversion of P. N0 is that initial number of molecules, P is the extent of reaction, while the Wx is the weight fraction of the X bar. So from here, so sometimes it asks about that if the number of conversion is given for condensation polymerization, so we can easily calculate its mole fraction, or we can easily calculate its weight fraction if you know about that this x value and this uh, percentage of conversion. So some related problem like from that assignment, like a step dot polymerization is 95% conversion. So already it's given that it's 95% conversion, and here already told us about is a trimer. So here x is related to the which mark you dimer or trimer or tetramer what is present. So if it is dimer, then x value will be 3. If it is dimer, then x value will be 2, like that. So you have to find out that mole fraction. So mole fraction will be ratio between that nx divided by n. So it will be like this equation, like 1 minus p into x minus 1, where that extent of reaction is given. So it will be coming around 0.95. X is the trimer is given, so x equal to 3. So from that you can get the mole fraction value. So like similar type of problem like when the for the cases of dimer or tetramer, so you have to change only that x value, and we can easily get that mole fraction value from this equation. So similar like application, how what fraction of like that monomer still is in the dimer condition. So for this like if you like the wx equation, the how much weight fraction in the dimer condition. So for the dimer, so now the x value will be 2. So you know about that percentage of conversion, if the 99% conversion. So the if you calculate the wx, so x value will be 2, and your percentage of conversion is 99%. You can put here, and you can easily get an idea that how much fraction of dimer is still remain. So here mainly the problem about that how much like during say classes that when you're doing the condensation polymerations, it's not about that up to 80% or 90% conversions, it's still in the dimer or timer condition. So at higher fraction like above 99% or above that, so then they are starting the connecting chain each other, and we get that higher molecular weight. But for the addition polymerization, curve will be like this. So from initial we get an higher molecular weight, then it will be steadily increase like that. But for that condensation polymerization or step growth polymerization, we curve will be like this. So only at above 90% conversion we get that high molecular weight. So that will suggest that up to 80% or 90% conversion, where some dimer, trimer are present into that polymer solution. So how we can calculate this dimer concentration or trimer concentration during this polymerization? So we can easily calculate like this type of problem. Similar like when we're doing that,
Sir,
yes.
in that case, if question 6 and 7, it was step growth polymerization is 95% complete, no, sir? Why we have taken 99% conversion for dimer?
No, here that maybe that here that must be your conversion is must be given here. Here there will be no relation between this
Given, sir,
that.
actually for question number 6 and 7, a step growth polymerization is 95% complete. So first
Okay.
question they ask regarding a mole basis trimer question.
Mm,
There we have taken 0.95, it is 95% correct.
mm,
But for 7 question also, we have considered 95% only. So we have got wrong answer during solving this, sir. I
okay.
don't know why we have taken
No, no.
99 here instead
Here
of
that
95.
that no. Here that nothing. So you have to take in the 95 here also, not 99.
Uh,
So if you ask them that what the right answer after giving your, like if you send some mail na, to professor or someone,
yes, sir. But
so they don't reply.
they told they will consider that.
Okay. So here the
So,
main here is given that the conversion.
hmm.
So your conversion not
Yes, sir.
related with the dimer or trimer, tetramer, not related with that.
Yes, they have told conversion is 95%
Yeah.
for
So
question
here
number 6
should be
and
that
7.
so that
Uh,
solution also they have given maybe wrong or something. They have given from the
yes,
previously
sir.
or like
They
that.
have considered 99% here.
So here should be that it should be 95, not 99. So in
Okay,
your
sir. We
exam,
should
if it
consider
is
the
yeah,
same, no?
in your exam
Hmm.
that what that percentage of like extent of reaction is given, so you
Hmm.
put that only. So it's not related with that dimer or trimer. So it's only that
Hmm.
what extent of reaction it will be happened.
Sure, sir. What is X, sir, here?
But
X, X.
so X is that what you are given. It's if you told about the dimer, so you have to take in X equal to
2 we
2.
have to consider.
Yeah. So
Hmm. Okay.
if it is
In
still
number
is
average
trimer,
also,
I,
hmm.
any cases. So X is related
Mole
with
basis
the
also N rep.
yeah.
In mole
So
base N represents, sir?
so here it will be tell na it's trimer condition, not dimer.
It
So for this
remains
reason,
3, but
uh,
N capital N here, sir?
capital. So it is the mole basis, mole fraction.
Ah,
But when you are talking about the weight fraction, so then that this equation will come
okay, sir. Okay.
in. So if you've taken 95%, then what the right answer it will come in?
But some answer around 7.84 during assignment, it seems, sir, and it was wrong that time while valuation because they have evaluated the same solution. No,
Okay. So it will be
they have
coming
got
around
some
2
wrong one. Mm.
into 1 minus 0.95. So the answer is matching with this or not? With 0.99.
No, sir, it was not matching for this, it seems, sir.
Okay. So it will be coming
You have
around
to
zero
take
point double zero four
195
nine
only.
five. Yeah.
Oh, okay, sir. Oh,
And it will be coming around 4.9 into 10 to the power minus 4.
yes, sir. Yes, sir.
So that should be right answer. So if in your exam, if it is coming, then you do like this, that
Oh,
what the extent of reaction is given and what it's
same
told, like
reciprocal.
that what what
Oh,
we want to consider, like dimer or trimer, then only you have to put this x, then all are it's
okay,
same.
sir.
Yeah.
Sure, sir. Thank you.
Okay. This question also they have that wrong answer, no? Hello?
I have got 396 minutes, it seems, sir. This question also wrong.
Yeah. This question also I have calculated during that time. So they have calculated it's wrong. So you have to remember this only that equation and how we can calculate this one. So this the acid catalyzed the polyesterification. So from this, if that you have to calculate that T at 98%. So here it is given that your 98% ratio and 99% is ratio is already given. We have to find out that calculate the time is required for the 99% conversion. So here it is told that 9. So here your T will be 99%. So from T 98%, your if the conversion is given, so you can easily calculate that ratio between this concentration at that rate constant. So if you get that concentration at rate constant here from C0 key, so it will be 4. This question answer you have matched with this. Hello.
No, sir, it was not matched.
So here, so it will be 49 divided by 196, right? It will be coming around 0.25 C0 K value.
0.25.
Yeah. So you are
Mm.
getting the C0 K value is 0.25. So now we put the
Yes, sir.
99%. So 1 minus, so it will be coming around 1 divided by 0.99. So it will be 100 minus 1. So 99 divided by 0.25. So it will be coming around 396, right?
Yes, sir, I have got 396 only.
Okay.
0.25 396.
Yeah. So this will be right answer, not this one. So maybe they are
Yes,
during
sir.
during this time they are doing some mistake in calculation. Like they are
Yes, sir.
from here that this 4 it's never coming is 4.
Mm.
So the so this also during so this question also you have sent, no? So they have not considered yet, right?
May not consider, sir. They have told they'll consider this week. Even in actually, even in first assignment, you solved, no, sir. Weight basis number average. In that question also, they did wrong.
Yeah.
The answers all.
Maybe they will.
This one, before one,
Mm,
everything. They told they'll consider, but definitely we don't know, sir, whether they consider or not.
okay, they must consider because so after
Yes, sir,
this
they
we
must
have
consider.
not related with
Mm.
this. Like I am not
Mm.
related with this. I am not checking the question paper. I am not checking anything.
Yes, sir. I
So
know.
I
Yes,
am
sir.
not. I am only taking this the doubt clearing session. So
Mm.
I'm not related. I can ask the professor to tell them like to consider this, but they are TA or someone.
Mm. Mm.
So earlier, like you have already told me, you sent mail. So for this reason, I am not
Yes, sir.
asking further.
Yes, sir.
So this will be last week. So maybe I am not asking after that also because
Yes.
after this it
Mm.
will be like from my end it will be complete.
Mm.
So if they are not considering, you can send some mail to professor and request
Mm.
to consider this.
Yes, sir. In question answers tomorrow, we will put once again, remind them to consider.
I
Mm.
now like a similar type of problem like when there will be when you are taking that excess of one monomer like that you are adding some monopenicillin impurity there that benzoic acid. So for this region you have to calculate your R value is changing. So earlier your R will be Na divided by Nb, but now if we are adding some monopenicillin impurity there, so your R value is changing. So now it will be like Na divided by Nb plus 2 Nb. So what the that mole of second monomer you are using. So from there you can calculate that your R value. So if you calculate your R value and if your extent of reaction is given, so you can easily calculate your degree of polymerization. Or here like that your Mn is given, weight is given, so you can easily calculate your degree of polymerization because you know about that what are the repeating unit molecular weight. So in this case it will be 113. So you know about that its conversion, so you can easily calculate its reactivity ratio. So you calculate its reactivity ratio like it will be coming around 1 or something, you calculate that. So now that Na is given it's 2 mole, Nb is given it's 1 mole. So now you have to find out that how much benzoic acid you need to add there. So if you put here the Na Nb value, so only that unknown value is your Nb into L, like what the monofunctional impurity you are adding here. So from there you can easily calculate that it's mole fraction. So how much you have to add there. So you have to remember only this equation. So when you are adding some monofunctional impurity there, so then that the second monomer like if you are Na divided by Nb, so if you are Nb you are adding, so your second monomer you are adding more excess. So for this reason you have to consider this equation, and from there you can calculate anything. If that Nb is given, Na is given, you can calculate the reactivity ratio. And if you know about the reactivity ratio and percentage of conversion, you can calculate Xn bar. And if the Xn bar is given and extent of reaction is given, you can easily calculate that R value. So now the next question is this question directly, if you know that equation, so you can easily directly you can get the answer that how the degree of polymation is related with that rate constant. So you can easily get the answer. for this extent of reaction how related with the rate constant, so you can easily get. So you have to remember only the relation between that extent of reaction and rate constant, extent of reaction with the degree of polymers like that. Okay. So like this question also in this week, na, like similar type of question. Hello.
Yes, sir.
So in this question they are doing right, or this also wrong.
Actually, we got 122, it seems, sir. I got answer for that. I need to check whether that is correct or this is correct.
Okay. So here also similar like type, like na. So 98% already they are given that this one at 80 minutes. So from there we can calculate that C0K, right? Then we have to find out that how much time needed for 99.5% conversion. So
Sir.
it will be coming around if you're doing like similar type of equation. So how this equation will be? So like this equation. So for 99%
Hmm.
it will be coming around 1 by 1 minus P minus 1 divided by C0K, right? So it will be coming around, so 1 minus P means 0. Now it will be 0.995 P. So 1 divided by 0.005, 1 divided by, so it will coming around 200, 200 minus 1. So above will be coming around 199. Now the C0K value. So C0K value they are given is 80 minutes, right? 80 minutes, and also this will be
80 minutes, sir. 80 minutes.
80 minutes, and it will be 98% conversion. So it will be
Hmm.
98%, so 1 minus 0.98. So 1 divided by 0.02, so it will be 50 minus 1, 49. Okay. So it will be coming around, so it will be 199. So your C0K value is will be 49 divided by 80, right? So 80 will be multiply here. So it will coming around 199 into 80 by the 49. So it will be coming around 324. So it will be coming around your, for the 99.5% conversion. So it will be coming around 324, right? So but here,
Yes, sir.
yeah, but here,
Hmm.
what tells the question? It will tell that the time required to increase the conversion 98 to 99%. Like at 80
Hmm.
minutes, it's already 98% conversion. So here it's
Hmm.
not talking about that how much time needed for the 99 conversion. So here talking about like that. So they already 98% conversion is already there. So that will take around 80 minutes, right? But when you are doing 99% conversion, so it will take times around 324 or 325 hours, like that, right? Did you understand that? Hello.
Yes, sir.
So then it's told that how much time required during this what the time duration between these two. So from 98 to 99%, so how much time required? So it will be required, so total time will be 324, and from there 80 minutes all the reaction will be done. So now from 98 to 99, so it will be takes that much time, like 324 minus 80, right? So it will be coming around 244 or 245.
Sir.
So did you understand this?
We have to again subtract at the end by 80, sir. If they have given 80 or else the what percent minute they have
No, no,
given
here,
from the
like
conversion.
earlier question, what tells about that how much time required 99% conversion. So you can directly get that answer from this equation, right? So from this here, 99% conversion, how much time required? So it will be times required around 324 if the 99.5% conversion. But in this question, they are talking about that how much time required from 98 to 99, not that overall time to complete the reaction at 99. So it will be takes about that from 98 to 99, how much time? Like you are doing some work, like you are doing in 3 days, you are doing something like 2% of work, right? And after 10 days, you are doing 80% of work, right? So,
Yes, sir.
so if you someone tell that from 2 to 80% work, how much time you takes? So total time you take like 10 days, if you consider. So in 10 days, 3 days, it's only taking for the 2% of work. So back that means that remaining days like 7 days. So in 7 days you are doing like 2 to 80. So total is 10 from the starting point, but from 2 to 80% work you have complete in only in 7 days. Like you have to minus that 2% work what you are doing in that first. How much time it takes, but in first 2% work you need to done. So for this reason, we have to the like here it takes about the 98% conversion. It will take around 80 minutes, and for 99.5% conversion, it will take around 324 minutes. So how much time duration between the 98 to 99.5? So it will be minus of this one, like 80 minutes already you have done. So the duration is between these two will be 324 minus 244. So this answer you have given right or wrong? You have done.
No, sir, I didn't subtracted with the 80. I got 324.
Okay. So here that in that question it will be given that the time required to increase the conversion 98 to 99.
Yes, sir. Same question.
Yeah. So
Hmm.
so yeah, like when there will be given that how much time required between these two, then you have to
Hmm.
subtract it. If
Subtract
it's
the given time for the first conversion
yeah,
percentage.
yes.
Sir,
So
I got it, sir.
if it will tells that how much time is required and 99.5% conversion, then your answer will be 324. So the total time, how much time is required? Okay.
Okay, sir.
Now that similar like we are doing that addition polymerization some problem. So from that how this initiator concentration is related with this extent of reaction. So if you remember this equation, so you can easily get that if you get some there, so it will be tells about that your extent of reaction is related with this by this ln equation. So from there you can easily calculate that ratio between the two initiator concentration. Similarly, that they will follow the first order kinetics. So if they are follow that only this that initiator degradation of initiator, so they will follow the first order kinetics. So from their first order kinetics is someone told about that your rate constant is given, the dissociation constant. So you can calculate that T half, or T if the T half is given, you can calculate that dissociation constant by this equation. With the first order, if the first order equation, so they will give this equation T of equal to 0.693 divided by K. Like if like radioactivity also, they are also follow this first order equation, right? So like similar type you can solve easily. So in this like similar type, you have to calculate that concentration when that entropy or enthalpy all are given. You can directly put this equation. So only thing you have to remember this equation, and during the calculation you have to remember that what unit we are taking. So similar type of problem, you have to find out that monomer concentration where that KD value is given, F given, initiator concentration are given, all of this given, so we can easily calculate this value. So then we are talking about some different type of initiation. Like for the redox initiation, some redox reaction is involved, some metal group is present there, some thermal initiation. So like some example of this thermal decomposition. So during thermal decomposition, so they are depending on the temperature. Photoinitiation, so you need some light to photoinitiate the molecule. So there will be some group like pi surface group are present, which will absorb your light there. So from there you can solve some problem like when that which will be redox initiator, which will be
Thermal.
thermal initiator, or which will be photo initiator. So so the above one is that like there will be some metal which will be related to that redox reaction, the electron giving and electron oxidation and reduction reaction. So that will be redox initiator. The thermal sign is already given, so that will be thermal initiator. If the light sign or H mu is given, so that will be your light initiator. Will be like this. Plus. So then you're talking about that some inhibitor or retarder. So how you can control that polymer molecular weight to adding some inhibitor or retarder there. So inhibitor means which can completely stop your reaction. Retarder means that slow down your reaction like that. So there will be some example like hydroquinone, parabenzoquinone, oxygen, which will be act as your inhibitor, or the retarder also some example carbon tetrachloride, nitroxide, phenol like that. So then that so during that are the polymerization synthesis process already done. Then the process of polymerization, how we can synthesize your polymer, like addition or condensation are the technique to synthesize the polymer. But that in the lab scale how we can synthesize, so there will be technique like bulk polymerization, solution emulsion, suspension polymerization. We can synthesize that polymer. So there will be some advantage or disadvantage of this technique like bulk polymerization, solution polymerization also discuss during their classes. So emulsion polymerization, how that surfactant is needed to emulsify, make some monomer droplet and micelle and that your polymerization will take place in the micelle. So here we remember that how the micelle will be look like. So generally that micelle will be lower in size as compared to that monomer droplet, and that your reaction will take place for the emulsion polymerization in that into that micelle. So like that we have solved some problem. So then we talk about some interfacial polymerizations to reduce that polymer viscosity like that. So you have to remove your polymer from that reaction mixture when there will be interfacial solution like two solvent we are using for that synthesis of polymer. So during the polymerization technique, so there will be various type of polymerization technique like ATRP, atom transfer radical polymerization, wrapped polymerization technique. So from the wrapped, we have to remember that what is the wrapped initiator concentration. So this wrapped reagent only take part in that your polymer. So you no need to taking about that initiator concentration and monomer concentration. But you have to taken care of that wrapped reagent concentration. So that will be comes for that your molecular weight calculation or degree of polymerization calculation. So here that wrapped agent is given 0.01 molar and your polymer is given 0.1. So you have to divide it by these two to get the degree of polymerization. So to calculate this percentage of conversion, so you have to going that this equation, the molecular weight is going to be Mn into M0 to Xn, where that Xn is related that percentage of conversion, how much converted that molecular weight divided by your initiator concentration, that your monomer concentration divided by its initiator concentration. So now that M0, that the repeating unit molecular weight is given, you know that percentage of conversion you need to calculate, and you are given like monomer concentration and initiator concentration. For the wrapped cases, the initiator will be like your 0.001, the wrapped agent, and when you are doing like normal condition like ATRP or some the normal initiator, so then that cases we are taking that initiator, because in that cases your initiator is connecting with the polymer, but for the wrapped polymer your wrapped reagent connecting with the polymer. So for this reason we are taking care of this wrapped reagent concentration here. So from there we can easily calculate the percentage of conversion if the molecular weight is given or uh, your M0 or Xn is given. So here similarly like that only that monomer concentration and initiator concentration is given. So for this reason we have taken care of that. If they are 100% conversion, so it will be P will be 1. So it will be into P, it will be 1. So for this reason we are not taking care. So it will be Mn by like M0, its initiator concentration is 0.001 into P by the 100% conversion, so P equal to 1, then into M0. So what will be here repeating unit molecular weight. Then you are adding some other monomer here, which concentration is 0.02. Their initiator concentration is 0.01, is similar like butyl lithium. Then the methyl methacrylate repeating unit. So from there you can calculate that overall molecular weight of this polymer. Then in the next classes we are solving some problem related with that, like that that When you add a polymer into the solvent, how this polymer solvent, how the polymer will be solubilized into that solvent. So like this Florey-Huggins parameter that will suggest like the for their normal molecule which will be easily soluble into the polymer. But for that polymer molecule it will take time to solubilize into the polymer. So that's first the solvent molecules comes and take part in between the polymer chain. Then that polymer become a little bit soluble. So from that we can know about that chi parameter, how this chi parameter, solubility parameter between solvent and polymer, if they are near about, then that will be better solvent, that good solvent for this polymer to solubilize that polymers. Then we calculate that RMS end to end distance. So from this equation we can easily calculate the end to end distance of that polymer. We can calculate that if the theta already are given, you can calculate the degree of polymerization. If the molecular weight and repeating unit already you know. So from there, your n will be your degree of polymerization. So degree of polymerization you can easily calculate here. Then you can calculate your end-to-end distance from there. From like similar type of question, how we can calculate that osmotic pressure from if like from the viscosity average molecular weight or something like that related. If the concentration are temperature, molecular weight all are given, we can easily calculate that osmotic pressure from this equation. So today's is what to this. Also knowing about some instruments, so how can we can easily get an idea about the DLS measurement. So DLS is measurement where that we can get an hydrodynamic radius of your polymer. So we can get an idea about your polymer radius or polymer size. So then we calculate that end-to-end distance. So the problem will be like that: two ends of the polymer sample nylon 6s is capped with COOH 8 gram sample found 8 into 10 to the power minus 3 COOH group by titration of alcoholic KOH. So here that KOH is given, and if there will be two ends is given, so the overall concentration of COOH is divided by 2. So for this reason we have divided this one is 2, so that will be given that overall COOH concentration, and from that we can calculate that number average molecular weight. So what will be given that 8 gram, and your concentration is given, which will be 8 divided by 2, so that will be coming into 4 into 10 to the minus 3. So from there we can calculate the molecular weight from the titration. So today is up to this. Maybe you do you have any further any doubts? Hello.
No, sir. Only I have some problems related issue with the week 2 and week 3. Anyhow, you have solved remaining all. I did very well assignments and I got that also. No need, sir. It is no
Okay.
need.
So
Okay,
then
sir.
best of luck for your exam.
Thank you so much, sir.
So you are in MSc or PhD or
No, sir, I'm teaching faculty.
so you are doing some like you are doing some work or you are in
Sir,
BTech
actually,
student.
my mm, PhD was polymer, so I took polymer as a NPTEL course. I selected that, sir.
Oh,
I
while
was doing in the field of polymer composites, PhD.
where
So I thought it may help me.
okay. So where you are doing PhD?
Sir, in VTU, sir. VTU from Bangalore, uh, under VTU.
Government institute or it's private?
Yes, sir, it's university.
So best of luck also your PhD journey
Thank you so much,
exam.
sir.
Okay. Bye. Then best of luck
Okay,
for
sir.
your
Bye.
exam.
Thank you.
And
Thank you.